example number 6 is a problem you've seen before. We have a boat who's traveling 24 kilometers upstream. So here's my boat. This is not a great boat, and they're making it look like a motorboat. So I guess I'll put a little motor on the back to make it look like a motorboat. And maybe we'll make the hull a little bit better looking. All right, so it's going upstream. And it's going upstream 24 kilometers. If it's going upstream, it means it's going against the current. So I've got a current that's going to go in the opposite direction. And I'm told that the current is 2 kilometers per hour. So I know the speed of the current. So first the boat goes upstream against the current. By the way, this is example 6. Told it goes upstream against the current, and then it turns around. It goes the other way. And my boat looks equally bad the opposite direction. Here it's going downstream, same distance, 24 kilometers. Write an equation that gives total travel time. So I want total travel time for the boat as a function of the boat's average speed in still water. In other words, if it didn't have the current. And if you remember, the boat's speed is always going to be the rate of the boat plus the rate of the current, right? And if the current is against it, you subtract the current, and if the current is with it, you're adding the current, right? So the speed of the boat is whatever it would travel if there was no current, and you're going to add the current if it's going downstream because the current is pushing it, and subtract it if it's going upstream. And the same thing for airplanes. Okay, so what we need first is our governing equation. And if you remember, D equals RT is the governing equation. Distance equals rate times time. But what are they looking for? They're telling us very clearly they want us to look for travel time. So what we first need to do is solve for T. And if we solve for T, in other words, if we put it in T equals form, we have to divide by the rate. Okay? And so to figure out this problem and find out what a total travel time, that means travel time upstream plus downstream. So we're going to list over here. First, it goes, I guess, upstream first. So upstream plus downstream. So if we look upstream, we have total travel time T. And we know upstream is going to be the distance upstream divided by the rate upstream and plus the distance downstream over the rate downstream. Well, what numbers can we plug in? Well, we know the distance is the same in both cases. And we don't know the rate of the boat. We're trying to figure out what the rate is in still water, but we know upstream, when it's going against the current, we're going to have to subtract the whatever it is, we're subtracting 2 kilometers an hour because it's going against the current. And downstream, it's the opposite. It's going to get help from the current. So we know that this is our basic equation. T equals, okay? So, but it's not simplified. So I'm gonna just change pages and we're going to rewrite this and simplify it. So we found that T, the total time, is the time upstream plus the time it takes it to go downstream, where this is the distance, 24 kilometers, over the rate, where the rate is minus 2 kilometers an hour when it's upstream and plus 2 kilometers an hour downstream. So we have a situation where we just need to find an LCD to combine these. The LCD is obviously going to be R minus 2, R plus 2. So we're going to say T equals 24 and multiply this by R plus 2 and also multiply the bottom by R plus 2. And we're going to do the reverse here and multiply by R minus 2 over R minus 2. And we end up with T equals 24 R plus 48 plus 24R minus 48, all of which is over R plus 2, R minus 2. So you can see that the 48s are going to cancel out, right? 48 plus 48 minus 48. So we're left with 48R over R plus 2, R minus 2. And that's as simplified as it gets. So we've answered the first question, and I actually didn't tell you what the second question was. The second question is find the total travel time if the boat's speed in still water, in other words, R, is 10 kilometers an hour. In other words, if that's the value for R. Well, we have an equation. All we need to do is substitute R into it, right? So our time is 48 times 10 over 10 plus 2, 10 minus 2. So we get 480 divided by 12 times 8. And if you do that on your calculator, you will find that this is going to give us 5 hours. Okay? So that is example number 6. And this concludes lesson 12.6.